Go Language Programming, Chapter 3, Unit 4. In this unit, we will go over passing the slice as a function arguments. And also we will go over how the append function, the built-in append function, which is provided in Go language, is used within the function body. Okay, so let's start with the passing the slice as a function argument. So whenever you pass a slice to a function, it will always be passed by value. Okay, so in fact, this is something to remember, that in Go language, nothing is passed by reference. Okay, everything is passed by value to function. So there are other data structures and within Go language that we'll talk about. So whenever you're passing anything to a function, it is always passed by value. You may hear from other people that, hey, Go language allows you to pass by reference. That is not true. Okay, you could pass arguments by pointer as well. Yeah, but then you have to declare a pointer as a pointer parameter in the function and so forth. So for the slice, it says slice data structure that is provided in Go, it will always be passed as a value as well. And the other data structure that we'll be talking about, the maps, for example, they will always also be passed by value. Okay, there is no such thing as reference. References has a different meaning totally. Like in C++, the references are given for the same memory that you are the originally memory that is allocated. You are getting the reference to the same memory basically. So it's two different concepts. So functions gets the copy of the slice, but the descriptor still will be pointing to the underlying array. So you see what is happening. So when you're passing a slice to a function, okay, in this case right here, we are passing a slice to a function. Okay, this is passed by value. Okay, now whenever this is happening, then the compiler, what it does, it makes a copy of a slice, okay, for the function, and the original slice doesn't, the original slice that is there, it doesn't actually get passed. So what is it getting passed right here? It is really actually passing the descriptor. Okay, remember the descriptor that we've been talking about? So this is a descriptor which has 3 items in there. So for the function, this descriptor might be sitting at address number 2000. Okay, and within the main, the descriptor, there will be a descriptor within the main. When we allocate the memory for the slice, it might be at some different address. Okay, so there are 2 different descriptors. So this descriptor gets copied, whatever is in this descriptor, including this address, into here. So within the function, so that's how they both will be pointing to the same underlying array that is out there. Okay, for the slice. So the descriptors are the one which are actually passed by value. Okay, and then once it's there, basically within the function body, as you can see, that it will have the access to the slice, the data which is within the underlying array, because it will know it, because this descriptor will be pointing to this array, and this descriptor also will be pointing to this same array. Okay, so when we are modifying this slice, you are essentially modifying the data within this array based on the slice. So use the slice to modify underlying array elements inside the function. Okay, and that's what we are doing right here. So the data will be modified. So when the comes back to the caller. So who is the caller? The main function is the caller for this function modify slice. Okay, so maybe we should start it from this main first. In this case, we create this array, underlying array, okay, with the 3 elements, and then after creating it, we call this modify slice function. The body of the function is right here, and then pass the slice. See, why do we say, even though we are using the array name int array, but we are using the slice, so in this case, what we are saying, pass the whole array, or actually a slice will be, everything, all using the slice operator. When we are using a slice operator, everything from that array will be accessible to this slice, which is within the body. Okay, and then when it comes out and do the printing, of that array, this array, it will print the data that was altered within the body of the function. Okay, because it knows that that underlying array data actually was altered by using this slice. Okay, so slices are always passed as a value to a function parameter. All right, so let's look at the other example right here that will tell us what slice passed by function. Okay, so we will basically, again, we are going to look at little different example and passing the slice right here to this function passed by value. Okay, and in this example 3-6, we have a package main, so we can compile this code as an executable. And then we have, in this example, we have a function. The name of the function is a slice passed by value. Okay, and basically we have a entry point function, which is a main, and in the entry point function we create a slice of 2 items, 2 strings. So basically, as you can see, the square brackets are empty, so that's why we know we are creating a slice. So this slice is not going to be empty, it is not going to be nil, it will actually will have a descriptor, slice descriptor. Okay, and it will have an underlying array with the 2 items in there, and this pointer will be pointing to right here, and the length of the slice will be 2. Okay, and capacity will be 2 as well. Okay, so that's how it will be created. Now when we are coming to here and saying that, okay, I want to see the address of the slice that was created, so I'm using an n% right here. N% is used, and so n% will give us where this slice was created. Okay, So when we do this, which address we are going to get? The address of this array or the address of this descriptor? Okay, we will get the address of this descriptor because descriptor is also in the memory, right? So when we do the n% in front of the slice name, we get the address of this descriptor wherever this was created in the memory. So that is the address of the descriptor. That's what it is printing. And then when we are printing the what the slice has, it will print this data, okay, before the function call. And then we are calling the function and passing the slice, okay. So this function can take a parameter of slice passed by value, okay. So that's what it is doing. So within the function body, we are using a slice, and we are saying that the slice element 0 and 1 must be modified with these new strings. So we are modifying it, okay. And then after modifying it, we are saying that print the function body, so basically so we are printing this data that is within the function body, so that whatever is in the slice has, it will print that right here, okay. And then we are saying that print the address. Now this n% slice fruit, that is the parameter name for this function. So when I'm doing the address, what address it should be? It will be totally different address. Remember, a few slides ago I told you, whenever you are passing a slice to a function, it will always be passed by value. So whenever it is passed by value, what the compiler does, it makes a copy of this descriptor, okay, and so it will be creating another descriptor, okay, and this descriptor, the original descriptor will be copied in here. So the address, this address, whatever the address is going to be, will be copied right here. So this will be also pointing to the same underlying array, and the length will be copied right here, and then the capacity will be copied right here, okay. So the address location for both descriptor will be different. This descriptor was created within the main, okay, and this descriptor is created within the for the function body, okay. So this will be for the function body, so it will be at the different address as well. So that's the reason these addresses are different, okay. This address is different than this address, as you can see that, okay. 8A000, this is 8A060, okay. And then once the function call returns back, it prints the new data from the slice, because it actually made the change within the slice. Why? How can it make the change? Because of this pointer is, the slice pointer of the for the or the descriptor for the function body is pointing to the same underlying array. Okay, that's how it made the change. So we will look at another example which relates to the pointer as well. So let's see. So slice passed by pointer to function. Okay. So in this case, we will see that the effect of the difference between passing the slice to a function parameter as by value, and slice pass to a function parameter as a pointer. Okay, so this is what we are going to discuss right now. So we have two functions in this case. One is name of the function is nil slice function, okay, and it is taking a slice as a parameter of type integer, and basically, when you pass a slice to it, it will do the same thing. It will copy the descriptor to a new descriptor, and both of the descriptor would be pointing to the same underlying array, okay. And in this case, only thing we are doing is printing or trying to get the address of the slice that is in the body of this function. So the address of the slice should be different for this descriptor than the one that was passed from the main. Okay, and then we also have a slice passed by pointer. Okay, and in this case we are passing so this is called the pass by pointer. You cannot call this pass by reference. Okay, that's again, a lot of people use these terms totally wrong. The references are not the pointers. Okay, and the pointers are not the references. Pointer means some memory which can hold the addresses. References means you have some name on top of the already existing memory, so which is the same memory. The pointers are actually created on different part of the memory than the actual data itself, so that's why they are not the same thing. Okay, so in here, what we're going to discuss the body, how it works. Let's first go in the main and go line by line and see what is exactly happening. So within the main body, we create a empty slice. Okay, so this is an empty, not empty slice, sorry, it is a nil slice. Okay, empty slice would be with the composite literal. This doesn't have a composite literal, composite literal with the curly braces, it doesn't have it. So this is an empty slice. Okay, this is a nil slice, sorry. And then we are calling this function and passing this nil slice. So when we pass the nil slice and do the printing, okay, within the function, and in both places, the address within the body of the function for the slice, and print the address from the body of a main for the same slice. Okay, so now notice the addresses are different, and we already talked about it. The reason that the addresses are different is because these are two different descriptors. One descriptor was created within the main, okay, where because of the main, and the second descriptor was created when this slice was passed as a parameter to this nil slice function. So that's why two different descriptor, and they both are actually are nil at this point. Okay, they both are nil at this point. So that's what, and if I would have found out, or had another print line right here to check if it is nil, they both will say true. Okay, and then this line right here in the main, at line number 25, I'm creating a slice. Okay, with a composite literal. Okay, this is a slice. The reason I say it is a slice is because in the square bracket is empty. Okay, so we are creating a slice of string, two strings, and we are using a composite literal to do that. And once we do that, this slice, my slice, will have the capacity 2, and the length will be 2. Okay, and it will be the descriptor pointer will be pointing to the underlying array. Okay, so the descriptor will be created once we do finish this operation at line number 25. And then at line number 27, what we are doing is we are saying that I want to see the address where this slice was created. So we are using the %. So basically, this is the address that it will print. Okay, so address will be printed, and then right after the address, I'm saying, okay, give me all the data before I actually call the function slice passed by pointer function. Okay, so I am basically giving the getting the data. Now, once I do that, and then since I have the slice, then what I'm doing is passing the pointer. Now, to pass the pointer to the function, slice passed by pointer function, the function parameter must be declared in such a way that it can take the address. Okay, so this is the way that you will declare. So the only really difference is that you put a star. Otherwise, if you don't have a star, then this is the pass by value. If you have a star in front of the left square bracket, then that means you're passing the parameter of the slice as a pointer. Okay. So once you do that, then you are calling this function and passing the this address. Okay, which address that you are passing? We just did the this address within the main, so we will be passing this address right here. Okay, so now in this case, when we are passing the address of the slice, of the descriptor, okay, the copy would not happen because we are basically creating the pointer, and that pointer will hold. So let's see right here, when we created this slice, okay, in the main, it was the descriptor was created, okay, at some address location. Let's say address 100 or something. Okay, and this address was the address of the slice. Okay, now when we are passing to this function, we are actually passing the address to the function. So we are passing this address where the descriptor is located. So within the function body, okay, within the function body, that same descriptor which was created within the main is available. It's not the copy of the descriptor which would be created in the main, like we saw it in the previous example, or even in this function right here. Okay, so it is the same descriptor, which is this one, will be the one which will be used. And since we are using the pointers, we have to do the dereferencing for the each element of the slice and put the data in there. Okay, so that way we have the data, and then when we do the this uh, printing of the um, address within the function body, we say slice address within the function body. Okay, and slice address within the function body is basically not going to be the same. um, it will, because of the pointer, okay, the pointer's address it is printing right now. So that's why this address is not the same as this address. So this is the address of the pointer that we passed into that function. So that's how the data is basically modified by passing the pointer of the slice, okay, and within the body, and we can alter, so in this case, or in the next example that you will see, if I use the append function, okay, in the append function, then it will actually will be able to append the more elements to the underlying array, okay, and it will be seen by the caller. Who is the caller? The caller is the main, and that's, we'll see it in the next example. But in this example, basically, you can get away without passing the as a pointer parameter, because this change is happening on the underlying array. So if you're just doing something like this, it's not affecting the underlying array, meaning underlying array, you're not deleting any slice element, or adding the more elements to a slice. It's not really going to be affecting. So then you don't have to pass it as a pointer, okay. If any of those things will be happening, if the underlying array will be affected, then you have to pass as a pointer, okay, slice pass by pointer. So basically, we, in the next example, we will use append, and you will see, of course, we already used append in the previous example, but in this case, append is used within the function body, okay, and you will see the difference in the previous example. When we use append, and we discussed that whenever you use append, it actually can grow the underlying array, okay. That's what the append will do. But now what we want to do is to use the append within the function body, okay. Previously we did not use the append in the function body. So we already discussed that the Go provides the built-in append function to add the data to a slice, okay. So that's what the append function does. And the signature for the append function is this. It has the the slice name right here. The first parameter is the slice, and then the second parameter is the data that you want to append. And as you can see, it has a dot dot. What does that mean? That means this append function is a variadic function that we covered it in chapter 2, okay. That means it can take um, uh, 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 any number of parameters. That's what this dot dot means. And of course, this append function returns a slice. That's why this is. So this is basically a signature for the append function. So the append function appends the elements to the end of a slice and grows the slice if a greater capacity is needed. Now, how is it going to grow the slice? It cannot stretch a slice. It will actually, if and especially if it cannot fit into the underlying array, it has to create a new underlying array, copy everything from the old underlying array to the new underlying array, pick up the address of a new underlying array, and put that address into the slice descriptor, okay. So that's how it can grow. So to use append function within the user function, now this is what we are interested in, how to use it. To use a user function within, to append function within the user function, the arguments of the function must be of pointer type. Okay, otherwise the change will not be seen by the caller. So in this case, main is going to be a caller of what? Of this function. Okay, so if you don't have, so in this example, what you're seeing is the slice is passed by a value. Okay, I'm not showing in this example. The next example will show you passed by pointer. So in this case, I am using, so let's go here first in the main body. So in the main body, I'm creating a slice. Okay, the square brackets are empty. I'm creating a slice of 3 integers using a composite literal. Okay, and basically, and then I am calling this modified function and passing this int slice to as a parameter to the function. This is passed by value. Okay, so it's going to be passed by value, and then I'm using a print line function to print. Okay, to print. So it will print. So this is the first print that it is going to print. But when I make a call to modified function, this function was called the body. So within the body, I have two. I am first trying to modify the zeroth element of the slice, not the array, zeroth element of the slice, okay, with this new data. And then I'm saying I want to append a new element to the slice. So when I do that, this is the time it will append. But the problem is that since the slice was passed by value, that means this function has a different descriptor. Okay, the descriptor is different than the descriptor which was created right here for this slice. So these are two different descriptors. Okay, because we are passing this by value, so these are two different descriptors. They are two different memory locations. So this descriptor, when you are passing, will be, but the one thing to understand also, that when you are passing by value, then the copy of this descriptor will be done. Everything that this descriptor has, okay, will go in here. Okay, so this descriptor will be pointing to the, so originally this descriptor, after when you created this slice, it created the underlying array right here. So this descriptor is pointing to this underlying array and holds all this data, 89 and 90 and 91. Okay, it holds all the data. And then when you make a call to the function, the compiler will make a copy of this descriptor and give it to the function. So now this descriptor, when it comes in here, it is also pointing to the same array. So this is a pointer in the descriptor. It will be pointing to same array. Okay, and of course the capacity and your length will be the same. And when we do this line number 6, that is modifying this zeroth element in the slice. So that will be 290. Okay, so that will become 290. Now it modified it, that's fine. And then after that, within the function, I am calling this append function. Now, what the append function will do? Append function will create a new array. Okay, when it creates a new array, that array will only be created and seen within the function body. So this will be a new array that will be created. Okay, and this descriptor, now this pointer will go away and it will be pointing to this new array. Okay, so this is no longer pointing to this original underlying array. This is the new underlying array was created within the body of this function once you did this append operation, append call to the append function. Okay, and then of course it will be created with the and it will write this number here in this one. So this array doesn't get affected. When the call returns to the caller doesn't see this array. Okay, so basically the append that you're trying to do, it would not happen. Okay, so for that reason you have to pass the slice parameter as a pointer if you want to use the append function within the body of a function. So let's see how that is done in the next example. Okay, so let's see it. So in this example, almost everything is really same. I have the modified slice function. The only difference is that now it is taking the pointer type parameter for the slice. Okay, and the body is exactly the same. It is using the append function, and it is going to modify the element of the slice. Okay, with the new data, and within the main, nothing is really changed. The only thing changed is now the call to the modified function is passing the address of the this array or the slice. Okay, the address of the slice is passed. So that's the key point. Now, when you are passing the address of a slice, so when we created this int slice, it created a descriptor. Okay, this is a descriptor, and then underlying array was created. Okay, this underlying array, and underlying array basically had this data in here, 1991. Okay, and this pointer from this descriptor for the slice, when we did this int slice, descriptor is pointing to right here, and the length will be 3 and capacity will be 3. Okay, so that's because we created that. Now after that, what we are doing, and then this descriptor was created at some address location, let's say 2000 address. This descriptor was created. So what we are doing is we are passing this 2000 because we are taking the address. So we are passing this 2000 to this. So now this pointer type slice will be holding this address 2000. Okay, so basically that means this will be pointing to, this pointer will be pointing to this descriptor. Okay, because we pass the address of the descriptor, that will be the pointer will be created. So this will be holding 2000 right here. Okay, and then when you're using it within the body of the function, you are doing the dereferencing right here. So when you do the dereferencing on that, what are you going to get? You're going to get this element, this array, underlying array, and that's how you're saying that I want this zeroth element. So you're writing this 290 to here. So now instead of 89, it will have 290. Okay, and then you use append function. So when you're using an append function, also the first parameter of append function is what? It takes the value. Okay, not, so that's why when you are doing the dereferencing on that, so when you do the dereferencing of what? This 2000, so you get this descriptor. So you're giving this descriptor, okay, to this append function, which knows where the underlying array is, and you are appending this one more element to it, and then it will return the new array. So basically it will copy all this because it doesn't fit in this array. So the new array will be created, okay, with maybe more than 4 element depending upon the compiler. So it will have all this data, with the 290 right here, and 90, and then 91, and then 75, uh, and then so 75 will be there, and 95 will be there, because we do the another append within the main. So basically this descriptor, once the new array was created by this append, which was called from within the main, within the function, the underlying array address will be put into this original descriptor which was there. It will be pointing to the new underlying array. Okay, so that's why you can append the new elements. Okay, and then when you do the another append within the main function, it is going to do the same thing. If the array, if it doesn't fit into the array, it will create another underlying array, copy everything that was done earlier by the append from the function body, and then it will print the whole slice. Okay, and then the any old underlying array were not used anymore, garbage collector will come and clean up. Okay, so that's how this append will work. Only if you pass the parameter to a function, or slice parameter to a function as a pointer. Okay, so this bullet says right here, the append element within the function, which is this function right here, modify slice, is available to int slice in the main function. Okay, so that will be the reason is because of the underlying because of the pointer that we passed. So that really concludes the this unit 4, chapter 3, and we will start the new one.